So David Attenborough most recently, not most recently, said lots of things recently, but relatively recently said, we are facing a man-made disaster on a global scale, our greatest threat in thousands of years. So I want to start by telling you how, or by sharing with you, how I came to be sitting here today talking to you about the climate and ecological crisis. Now, if any of you know much about my career, until a year and a half ago, I knew absolutely nothing. I'm going to put my hands up here and say I knew absolutely nothing about climate change and the ecological crisis. Now, that's slightly underselling myself. You know, I did a degree in natural sciences. I did a PhD in molecular biology. Of course, I've studied some chemistry, some biology, and I understood about climate change even from school. But relatively speaking, I knew very, very little. And I want to tell you that because I want to tell you, first of all, I'm not a climate scientist, but I've spent the last year and a half going on a deep dive to find out everything I could about what's going on the planet. From a place of knowing very little, because the whole point is, unless you're a climate scientist, it's very hard to actually really know what's going on and what's true and what to believe. So it all started for me about a year and a half ago, April 2019, when I attended the second Extinction Rebellion protests, simply to support my partner, Kim Wei, who's also on this call, who was leading and playing in the samba band. Now, I went along to the protests, being a sort of diligently supportive partner. Kim Wei's pronouns are he, him, by the way, so I'll refer to him as he, but you can see he's assigned female at birth, just to avoid confusion. So he and I went along to the rebellion. Kim Wei was drumming. He was also singing songs on the pink boat in the middle of Oxford Circus. And I was kind of being a very supportive partner, but also thinking, goodness me, like, what am I doing here? What is going on? And quite frankly, I felt really uncomfortable because I was looking around and I was seeing banners and placards and people shouting, you know, a mass extinction and societal collapse and civil unrest, and we need to change the course of history now, and millions or billions of people might die. And I'm thinking, really? I feel very uncomfortable here. Is it really that bad? So given that I'm a science communicator, given that I've got a relatively big public platform and following on social media, there was no way that I was about to start talking about my being at the protests, even just being there, without really getting to the bottom of like whether it was really as bad as all that. And honestly, my instinct was like, nah, it can't be. It can't be that bad for three reasons. Number one, I thought if it was really that bad, then surely it would be on the front page of every newspaper. It would be top of the bill on every news report. And it isn't. So quite frankly, nah, I don't believe it. They must be alarmism. They must be kind of making a big song and dance about this. My second reason was that I thought, okay, if it really is that bad, and even if the media aren't telling us, surely the government knows. And surely if the government knows, then they would be doing something about it. So maybe it is that bad, but they're on it. How naive I was. And my third reason was a bit more personal, which was, as I've sort of mentioned, I'm a science communicator. I've dedicated my life to finding out the truth about the world, to getting to know what's right and what's wrong, and to communicating that truth to people. I'm also autistic, so I have a real desperate sense and desire to speak the truth, to find out the truth, to speak the truth. I can't lie, and to kind of get underneath, you know, what people are saying. So I thought, you know, given that I've dedicated my life to this and I've given tons of talks on different science topics across the world, no one's asked me to give a talk on climate change. I'm not saying there haven't been people giving talks, but I was just like, it's not really on my radar. And arrogantly, I thought, well, if it's not really on my radar, it can't really be that much of a big deal because somebody would have asked me about it. Again, how naive I was. So what I decided to do, literally on that day, I was like, okay, if I'm going to even be seen at this protest, let alone get on board with it, then I need to make sure that I really find out the truth about what's going on. So from that day, I started to go on my own sort of special interest, shall we say, deep dive into finding out what's going on the planet. And, you know, I've done a PhD, I've been a research scientist, I know how to research information. I will say that, you know, I know which sources to read, which journals to read, which experts to speak to. There were already some great climate scientists who were on board with Extinction Rebellion, a few who are on this call today. who were there to talk to, who gave me so much of their time. I was asking them questions, getting them to explain stuff, saying, well, is it really that? So I knew how to find stuff out. And the more I read, the more I researched, the more horrified and the more terrified I became. And I can honestly say I have not had a single good night's sleep since. Because what I found as I read and expanded my knowledge was that not only were the things on these placards, the things the activists were saying, not only were they true, but actually things were, if possible, even worse. That there was a lot that wasn't being said, that hasn't been talked about. And it became this obsession of mine. I was like, I have to get my own head around the truth. And I have to make sure that as many people out there as possible know the truth. Of course, there's lots of other people out there trying to get the truth out. I'm not on my own on this one. But I just knew from that moment that the only thing that had any integrity in my life was trying to find out everything I could and trying to get it out there. So what I'm going to do for the next bit of the talk is give you an overview of what it is that I found, to get combined with some brilliant experts, climate scientists and ecologists from the Extinction Rebellion community, what it is that I found with their help, a summary of what I see as the most important things for people to know about what's going on the planet, why, where we're heading, and what we can all do to help. So the first thing to share is that if you look at this graph here, I won't be showing too many graphs, so hopefully they'll be quite simple ones for anyone to understand, is that these are the global temperatures over the last 150 years or so. 150 years is chosen as the sort of the period that we tend to look at, because that's the around the beginning of the middle of the Industrial Revolution, which is when things really started to change. And as you can see, the colour stripes show us that, the last 4 years have been the hottest on record. 19 of the hottest 20 years on record have been in the last 20 years. And there is absolutely no doubt that global temperatures are rising. You can see here that this graphic shows temperatures, how things have changed in the last sort of 10 years or so. And you can see pretty universally that the temperatures have gone up. Now I say pretty universally because it's obviously important. We're talking about average changes. There will be parts of the globe that have got colder. Lots of skeptics always say, oh, it got colder where I live. Well, yes, of course, we're talking about global averages. You have to look at long-term trends. Short-term change, that's the weather. Of course, some places are suddenly a bit colder. Some areas of the world are actually colder in a given year than the year before. But if you look at the long-term trend, there's dips and troughs, dips and troughs. You look at the long-term trend, global temperatures on average are going upwards on the majority of parts of the world, particularly at the poles for a variety of reasons, and that's particularly problematic. And if we look at this in context, again, you're going to need the right-hand side of the screen here. If we look at this in context, if we look at the last 2,000 years, you can see that temperatures have gone up and down. You can see these squiggly lines. If you look at the invention of the steam engine down sort of bottom right, that was around 1800s, Industrial Revolution. And then our temperatures just start to absolutely skyrocket. Now, I say skyrocket, they've actually only gone up by about 1 degree. You can see that, right? But if you look relative to the fluctuations that there were before, that really is a lot. And in fact, our global temperatures are higher now. It's almost certain they're higher now than they have been at least the last 100,000 years. That's a long time. And the point is they're going up very, very fast. Now, 1 degree C may not sound like very much, but averaged over the whole of the globe, to get the amount of heat in our atmosphere to raise the temperature by 1 degree, that's an awful lot of heat, And 1 degree is actually the equivalent of 5 atomic bombs going off in our atmosphere every second. That's the equivalent heat energy that's being released into our atmosphere that has caused, today that is, that over the last 150 years averaged out, has caused a rise in 1 degree. Remember, 1 degree as well can mean the difference between water and ice. 1 degree in this context is a lot. So the next question people tend to ask is, okay, so yeah, fine, temperature's going up, but so what? Maybe it's something natural that's going on. Can we really be sure it's humans? Well, yes, we can. And let me just give you some arguments to combat skeptics on this topic. It is unequivocal now, but if you're still not sure, Here's just a little bit of background basic climate science. Forgive me if this is kind of too simple and very known by a lot of people here, but some background climate science because it helps us understand how we know for sure that the rise in temperatures is due to us. So first of all is that the sun shines its heat on the earth heats up, and the earth radiates that heat back out to space. Luckily, we have a layer of gases around the earth called greenhouse gases, such as carbon dioxide, water vapor, methane, that help trap some of the heat radiating from the earth and keeps us warm. We need that layer. That fluffy blanket keeps us warm at night, otherwise we'd all be too cold and we'd die. However, we also know that these greenhouse gases in the atmosphere that make up the fluffy blanket are increasing. In other words, the blanket is getting thicker. Now, some people say, okay, well, if we're getting hotter, maybe it's not the blanket getting thicker, maybe it's because there's extra activity from the sun. That's a common argument from skeptics. No, if we look at the graph, solar activity kind of goes up and down a little bit, but the global temperatures scoop up like that. And in fact, what we can see is that instead, the increase in global temperatures over the last 100 years or so is mirrored by the increase in carbon dioxide, one of those key greenhouse gases in the atmosphere. Another thing that people often say is, well, you know, carbon dioxide in the atmosphere, maybe that's due to natural causes, maybe that's nothing to do with us, maybe we should just follow what the Earth is naturally doing. Well, okay, look at this graph. So this graph shows carbon dioxide levels in the atmosphere for the last 800,000 years. Carbon dioxide levels go naturally up and down, partly driven by the sun's natural variations in its orbit, the Earth's natural variations in its orbit around the sun, known as Milankovitch cycles. The point is that causes changes through a variety of knock-on effects, causes changes in carbon dioxide levels in the atmosphere. So yes, there are natural changes, but look at them going up and down over the last 800,000 years. That's what drives the Earth in and out of the ice ages, because when carbon dioxide levels go down, the thickness gets, the fluffy blanket gets thinner, so we're not as warm, and we get colder, we go into the ice age, and then we come out. So yes, that is very natural, Earth's natural cycles, that does happen. But look what's happened on the right. So our global carbon dioxide levels now are not only higher than any time in the last 800,000 years, but also any time in the last 3 million years. Plus, our natural cycles should actually be sending us towards our next ice age in the next 1,500 years or so, not hotter, which is what we're getting. Plus, we're getting hotter, we are getting hotter, but our carbon dioxide levels are increasing at a rate today hundreds of times faster than any of the natural increases that took us in and out of the ice ages. So anyone who says, oh, it's just Earth's natural cycles, absolutely categorical, it is not. Show them this graph. Okay, so one more piece of evidence that kind of nail in the coffin really is that there is now actually a human fingerprint on climate change, which shows that the carbon dioxide is coming from fossil fuel burning, which has been happening in huge quantities since the start of the Industrial Revolution. The burning of the fossil fuels releases lots of energy, which is great for industry, also releases carbon in the form of carbon dioxide that's been trapped in the fossil fuels that were formed millions of years ago deep under the oceans and under the rocks. And that carbon dioxide has been shown to be the same carbon dioxide that's now adding to our atmosphere, making the fluffy blanket, the greenhouse gas layer, get thicker. And it's been shown that it's that greenhouse layer that is trapping more heat through satellite data. It's been shown through isotopes that it's the same carbon. So it is absolutely certain now that it is this carbon coming primarily from the burning of fossil fuels, but also lots of other ways, which I'll come back to, that is thickening the blanket, that is making our atmosphere warmer. Absolutely no doubt about it. And it's not the only greenhouse gas. We'll talk about some others in a moment. So, you know, according to the top experts, in just 100 years, fossil fuel use has undone more than 5,000 years of natural cooling. Remember, we should be cooling. We should be going towards an ice age. It's hotter now than any time in the history of human civilization, and we're catapulting ourselves out of the Holocene, which is the climactic sort of stable climate period we've been in for the last 12,000 years or so, or maybe a bit less, since the last ice age kind of thing. Well, 12,000 years since last ice age, we've been in the Holocene probably about 5,000 years, I believe. But it's catapulting us into uncharted territory, into now what is called the Anthropocene, the era that is being controlled by human action, where the climate is being controlled by human action. So what's going to happen? What is happening already, and what's going to happen as a result of all this extra heat in the atmosphere? Well, the first thing, which is pretty obvious, but I'll take you through the science of it, because again, there's some people who kind of might doubt some of this, is more extreme weather. We've actually seen that the climate has already changed. Climate change has already changed our weather patterns and is having adverse effects on people's lives. So since the 1990s, the number of disasters, specifically here extreme weather events, has doubled from the 1990s going up to 2010. And more recent data that I haven't got a graph of shows that from 2010 till this year, in the last decade, it's almost doubled again. So we're talking storms, wildfires, extreme heat, droughts and floods. Now, a lot of people might think, okay, well, it's obvious that if our global temperatures are getting warmer, 1 degree, that's not very much. But the point is we get more extremes. So we get extreme heat. So we get areas of the globe, including the UK, including Europe, but particularly in parts of the global south and in less developed countries, this is extreme heat in Kenya. And extreme heat then leads to droughts. So this is in Kenya, we've had, where there's been horrible droughts in the past, in Ethiopia, this is in Laos, and even here, this is actually a picture taken here in London. I say here, I'm not in London, but some of you might be, of extreme heat causing real distress in major cities around the world. So this is already happening. Thousands of people are dying every year in this country from heat stress, from particular heat waves. And it's been shown, there's been lots of attribution studies to show that heat waves are made 10, 20, 50, 100, 600 times more likely due to climate change. And this is now well documented. It's not just like, oh, it might be. It absolutely is being made more frequent. It's going to happen more and more often because of climate change. And of course, we don't just have heat-related deaths, but we also have heat-related diseases. It exacerbates asthma and lung diseases and all sorts of other challenges that come with the heat. But it's not just heat that happens. Of course, when you get extra heat, the soils dry out, the trees and the vegetation dries out. So you get hot areas, don't just get hotter, but they also get drier, because when it's hot, clouds can't form as easily. Very simple physics. So you're more likely to get forest fires. Yes, actually most of this has been debunked, but some of them might have been started by arson. Mostly actually they weren't. But even ones that are started by arson, the point is they spread faster. They spread quicker, they spread faster, and they spread more. So this is a fire actually quite a while ago in California, but the forest fires in California this summer, they've now been called, what are they called? They were called mega fires, and now they're called, gosh, it's just gone out of my brain. But the fires are now covering 1 million acres this year, which means that there's a new classification of fires required. 5 of the 20 biggest fires in California have taken place this year. And these are happening more and more because of climate change, because of the drying of the soil, because of the hotter temperatures means that the fires can spread. There's of course been terrible fires in Australia and in many other parts of the world. In the fires in Australia last year, it's estimated that 1 billion animals, creatures, and I think that's actually only mammals, were lost. Insects and other creatures, huge load more. And of course, we're losing the habitats of animals, and I'll come back to wildlife loss in a moment. So this is absolutely linked to climate change. But then of course, not of course, I'll explain why, we also get floods. This is in Indonesia. In fact, I'll show you some more pictures in a moment, but let me just explain for a moment. So why does extra heat in the atmosphere cause more rain? Well, very simple physics. Rain is caused by evaporation from the oceans. The evaporation is driven by heat in the atmosphere. Water in the oceans evaporates. We get more water vapor in the atmosphere when it's hotter because there's more evaporation. Also, when it's hotter, the air can hold more water vapor. It can hold 7% more water vapor per degree. So you get more water vapor in the air. What this means is that when the conditions are right for clouds to form, either it rises high enough or the temperature cools down enough, those clouds that form, there's going to be more of them, and they're going to be thicker, and clouds can be thicker, but they're going to be more dense, and the rainfall is going to be heavier and more intense and more frequent in the areas where rain was forming before. So areas that are already wet are going to get wetter, plus, or are getting wetter, I should say. Plus, we've got the fact that scientists think that the extra heat in the atmosphere might also be interfering with the jet stream, which is something that drives our weather cycles. And the jet stream is being made to go a bit more wavy rather than more straight through, which means that weather systems linger for longer, which means when you get an extreme heat wave, it lasts for longer. When we get extreme rainfall leading to floods, it lasts for longer. There's more downpours for a longer period of time, leading to far more chance of flooding. So we've got terrible floods over the last few decades, getting more and more frequent. These ones are Indonesia, some really heart-wrenching pictures of people struggling. We've got typhoons in the Philippines. So it's not just floods, it's also tropical storms become more likely with more heat in the atmosphere. The tropical storms whip up more water from the oceans, they dump more water, they're more destructive. Typhoons, hurricanes, etc. This is Haiti. Some really moving pictures from the devastation in Haiti from storms. This is landslides in Peru as a result of heavy rainfall. We've also got flooding in New Orleans. This is just some examples over the last sort of recent years. And in America, they're actually finding, this is in South Dakota, they've actually found that this year in 2020, there've been so many hurricanes that they've run out of names. So they've actually had to gone through all 21 names through the alphabet. They only used 21 letters, and they've had to start again. And it's only the second time that that's ever happened because there've been that many hurricanes. And it's not just far-flung parts of the world. There are many cases, these are all cases here in the UK, of floods which have been made more likely, significantly more likely, or even impossible in the absence of climate change. Places like Yorkshire, Gateshead, Northumberland. This is in Cornwall, in Fowey in Cornwall. This is in Buckinghamshire. So it is happening on our doorstep. And the point is, if we listen to the experts, it's going to get worse. These records will be broken in a few years. We had, in 2016 was the hottest year ever so far. I think it may be moving towards 2020, I'm not sure yet. 2019 had the hottest month ever recorded, July 2019. There were nearly 400 temperature records broken in 2019. That's a lot of temperature records. This year, 2020, we've had the warmest January, we've had the wettest February, we've had the warmest May, we've had the warmest the wettest October, we've had the warmest September. We had a month's worth of rain in one day in October. And so much rain that it could fill Loch Ness in one day in October in the UK. There's records being broken everywhere, and it's going to get worse. We're going to start to see the extreme end of the fire behaviour scale getting even worse. And we're going to see many more Harveys, Hurricane Harveys of that type in the future, and possibly even here in Europe and in the UK. So the point is, it's happening. It's happening already in other places. It's happening to some extent here and in Europe, and it's going to get worse. And just because it's the poor that are suffering today in the global south and in less developed countries, necessarily, even if we're heartless and we don't care about it happening not on our doorstep, it will happen here. The rich will suffer tomorrow. So world leaders should be listening to the scientists. They should be listening to the people who are struggling with extreme weather events right now, because humanity won't be able to cope with what we're heading for. So what are the other effects of the extra heat in our atmosphere? So another obvious one is melting ice and rising seas. So we see that as the temperature has risen, the sea levels have also risen. Now that's twofold. First of all, as the temperatures rise, ice melts. And of course, as ice melts, we have huge problems for creatures that live on the ice. It's a bit of a poster child for climate change, but the polar bears, if we allow all the ice loss to continue, which it is doing, all the polar bears will soon be gone. But it's not just polar bears. It's all the other parts of the world that are covered in ice that need that ice. So for example, we're losing glaciers. There's 1.9 billion people across the globe that depend on freshwater glaciers for their drinking water and for crop irrigation. We're losing those glaciers. We're losing land sheets on Antarctica and on Greenland. This is a dried out glacier in Austria. So we're losing, as we lose sea ice, then polar bears can't hunt. But in terms of sea level, that doesn't make a difference because the sea ice just melts into the sea. The problem is when we lose land ice, so that's Greenland, Antarctica and the glaciers, which we are losing at a terrifying rate, the amount of ice that we're losing on our planet, if we average it out over the last 40 years, it's the equivalent of losing 300 double-decker bus-sized chunks of ice every second. That's how much ice we're losing. Yeah, to me, that's absolutely astonishing and terrifying. The point is we're losing it really fast, and that is going to cause knock-on effects, Because the other knock-on effect of losing land ice, like glaciers and ice sheets, is that that ice melts and goes into the oceans and causes the sea levels to go up. Plus, as the oceans get hotter, the water expands, it's more basic physics, and the sea levels go up. The point is we are seeing sea level rise. The impacts of sea level rise is already happening. It's already devastating local communities, coastal and river communities, and it is going to get worse. The impact on families is going to be enormous, particularly in areas such as the Gulf Coast and areas in the UK that are around the coast, that are around our river estuaries, that are moving towards the point at which they're going to be below sea level at high tide. And there's some areas of the country that are already like that. This is the Marshall Islands that are already being lost to sea level rise. It's predicted they're going to be disappeared by the end of the century. And it's not just far away things. This is in Norfolk, on a beach in Norfolk, and we've got houses are literally crumbling into the sea due to erosion, due to sea level rise, due to storms. It's interconnected crises that are all happening due to, well, erosion is also partly natural, but the sea level rise and the extra floods and storms are also added to by human action. In addition, the extra heat in the atmosphere heats up the oceans, doesn't just cause the oceans to expand, but it causes the life in the oceans to diminish. So, for example, fish and creatures living in the oceans are suffering from marine heat waves, which kills a lot of the ocean life. Plus, extra heat in the oceans causes the oxygen dissolved in the oceans to actually, a lot of it to come out of solution. So we're getting areas of the oceans that are low in oxygen, which means that, again, sea creatures can't live there, what's called ocean dead zones. Plus, particularly to do with the coral reefs, which you can see here, the extra carbon dioxide in the atmosphere from the burning of fossil fuels can dissolves in the oceans, making the oceans more acidic. So they're supposed to be alkaline, they're still alkaline, but not as alkaline. They're 30% more acidic than they were before the Industrial Revolution. And that's causing catastrophic damage because sea creatures living in the oceans require the alkalinity to form their shells. In the slightly more acidic conditions, the shells just start to dissolve. So coral reefs, sea snails, oysters, clams, their shells are literally dissolving. And we depend on these creatures, partly because they're the bottom of the food chain. 1 million different species depend on coral reefs, but also there's 1 billion people across the planet that depend on coral reefs themselves for protection from storms, for tourism, for fishing, for food, for their livelihoods. These are not just beautiful things in the ocean, these are things that we depend on. So that brings me on to what are the knock-on effects of these devastating impacts that we're seeing already. So everything is connected, and it's very, very complex. One thing affects the other, which then feeds back and affects something else. But the bottom line is that climate change impacts everything. Everything sort of is damaged, affected, impacted by changes in our weather systems. So, for example, and there's so many examples, I'm just going to go through a couple, access to food and water. So it's really clear that climate change is already causing reduced crops, reduced nutrition in crops, reduced crop harvests. There's the last 2 years, the last 2 out of the last 3 years have had really severely reduced harvests here in the UK, but we can't see it so much because we import a lot of our stuff. So it hasn't really, the impacts haven't really shown up yet, but they will. And the point is that as areas across the globe get hotter, there's droughts, there's more floods, then the areas that are producing crops are more and more likely to fail, and some of them are already failing. So we know that with increased storms and floods and droughts and heat waves, production of food will be more problematic. Production of nutritious food will be more problematic, and that's already happening. Plus, access to clean, safe drinking water will become more difficult. And it's the head of the Met Office has said that he finds it hard to see how the population of the world will be able to feed itself if we allow things to keep on going as they are. And the former president of the World Bank has said that climate change will lead to battles for food. We've also got impacts on health. So apart from heat-related illnesses, which are in the thousands just in the UK, tens of thousands of people dying from prematurely due to heat waves across Europe in some of the big heat waves over the last decade. But there's also other impacts. Climate change poses the biggest global health threat of the 21st century. Why? Because not only do floods and storms and heat waves and extreme weather damage and kill people, but also increasing global temperatures cause the bacteria that spread diseases to be able to thrive better. So it's more likely that they're going to be passed on from person to person. And we're already seeing outbreaks of diseases that have otherwise been eradicated, such as malaria, outbreaks in parts of the world where it was eradicated, such as malaria coming back in Europe. There've been incidences of Zika virus in this part of the world. So, and this is directly linked to increases in global temperatures, to changes in the seasons, to changes in the migration and the proximity to humans of animals, because that brings me on to the obvious thing, pandemics. So there's a lot of evidence now to show that the COVID-19 pandemic was passed from bats to humans, and I think possibly via pigs, but it's not certain. But the point is that pandemics are far more likely to happen because of the fact that humans are intermingling more with animals, because we're kind of cutting our way into animals' habitats. I'll come to animals in a moment, but that means that we're mingling with animals. That means we're more in close proximity with animals, which means that animals are more likely to pass diseases on to other animals and then on to humans. So there's a variety of reasons why human health is threatened directly and indirectly by climate change. And it is particularly impactful on the elderly and on children. And these are the people that are the most vulnerable that we really need to protect. Another knock-on effect is migration and displacement. So the civil war in Syria, lots of complex factors as to why that came about, but there's a lot of evidence now to show that climate change played a role in it. And this is Syrian refugees in Hungary trying to get to Germany, not being allowed on the trains. And in the first 6 months of 2019, a record 7 million people were displaced due to climate impacts and extreme weather. So, we're going to see a lot more displacement. And if we imagine what that's going to do to the stability of our society, to human rights, this is something that's already happening, and we're going to have more of it. So that brings me on to what else we're doing to our planet. It's not just what we're doing in terms of carbon dioxide release from fossil fuels and planes and cars and trains, but it's also a huge impact is deforestation. We've now lost around half the trees that we had at the start of agriculture. That's about 3 million trees. And we're losing about 15 billion every year. In parts of the Brazilian rainforest, trees are being felled at the rate of 3 football fields every minute of Amazon rainforest being lost. Now, deforestation, first of all, we lose the habitats of animals, which is hugely important to maintain the balance of our ecosystems on the planet, which I'll come to in a second. But also, trees are a very important way of trapping carbon dioxide from the atmosphere. The more that we chop them down, the more our greenhouse gas layer is going to get thicker because they can't get trapped by the trees. And in fact, when you burn the trees, it actually releases that carbon back into the atmosphere. So it gets even worse. So deforestation to feed the planet's ever-increasing demands for palm oil and for food products and for grazing and for livestock and for agriculture, this is a huge, huge problem. And it feeds into climate change. So sort of feedback loops. We've also got intensive agriculture. So we've got the fact that we're using up more and more of our land to grow crops, but particularly for livestock. Livestock is the absolute biggest problem, because farming livestock and actually farming crops using monoculture, so intensive agriculture, churns up the soil. And when we churn up the soil gets damaged and degraded. We've now lost about 1/3 of our soils across the planet in terms of damage and degradation. Not only does that mean it's harder to then grow more crops in the future, but also that soil actually contains a lot of carbon. And as we damage the soil, the carbon gets released back into the atmosphere, even more greenhouse gases in the atmosphere. So it's all just kind of like ramping up as we go. Also with intensive agriculture, we have chemical fertilizers. Fertilizers release nitrous oxide, which is a very, very potent greenhouse gas, even more potent than carbon dioxide. And then when we farm livestock, cows and sheep are ruminants, and they burp and fart methane. And cows burp and fart enormous quantities of methane. And methane is another very potent greenhouse gas. So not only that, but actually, even though 80% of our farmland is used for farming livestock, it only produces less than 20% of our calories and only about 1/3 of our protein. So it's a very, very inefficient way of using the land, not to mention all the methane that gets burped out, plus all the fossil fuels to drive the tractors and the compaction of the earth from the tractors. It's damaging our soil, it's damaging the environment. Of course, we have to eat, but this is a particularly inefficient use of land. And we could free up an enormous amount of land if we switched away from big agriculture and if we switched away from livestock farming. And experts have said that actually going vegan is the single biggest way that we can reduce our impact on the planet. That's a very contentious issue, I'm aware of that, but it's definitely something to think about. Another issue that we're doing is that we're creating is pollution, both in our waters. We all know about plastic pollution in the seas and how absolutely devastating that is for sea life, but also pollution in the air. There's an air pollution pandemic. An estimated nearly 4 million people die every year as a result of outside air pollution. Just wanted to get that figure out. Around 4 million people every year as a result of outside air pollution. 9 out of 10 people on this planet breathe polluted air. In London alone, 24 people die every day due to air pollution. So this is another linked in impact that we're doing to our planet, mostly from chemicals from car exhausts and from transport and from burning fossil fuels in factories. Not just that, but that's a large part of it. So that brings me on to wildlife. We're losing our wildlife at catastrophic rates. Now, this is a mixture of climate change, which is causing wildlife to have to migrate to different areas because it's getting too hot or too dry or too wet for where they normally live. Also because of changes in the seasons, because of changes in the weather systems, means that the seasons are starting earlier or later in different parts, so wildlife has to migrate. And the problem is that there's nowhere for a lot of these creatures to go because so much of our planet is degraded by human action. They try and get somewhere colder, they try and go up a hill, or they try and go further north, and there just isn't anywhere for them to go. They've been cut off, or those areas have been degraded. Plus, damage to wildlife comes from pollution, comes from chemical fertilizers, pesticides, it comes from habitat loss and destruction of natural habitats. And we're actually, if we continue to lose the wildlife as we're doing, even the smallest organisms that we're losing, we destabilize and ultimately risk collapsing the world's ecosystems. So our vertebrate population sizes are now down 60%. In fact, the recent figure is now showing 68%. So it's increasing as well. Numbers are going down. That's a staggering loss of vertebrate population sizes. 1 in 4 species are now at risk of extinction. And there's 1 million species that are now threatened with extinction, many of which over the coming decades, unless we take radical action, and we take it now. The UK is one of the most nature depleted and nature challenged parts of the world. 1 in 4 British mammals also at risk of extinction now. And when we have changes to our animals, it impacts us in many ways. So this is an example of crops rotting where because of changes in the climate, parrots came in at a different time of year than usual, and they fed off the crops when the crops were supposed to be being harvested. There's many ways in which animals impact our crop's life, and particularly is through insects. We can't survive without insects, and there is a staggering loss of insects going on this planet, again, for all the reasons that I mentioned. Insects are particularly important because they pollinate our crops, and 95% of what we eat relies on healthy soil. We're losing our soil, like I said, and we're losing our insects that pollinate those crops that allow them to grow. And we also rely on small creatures like earthworms to replenish the soil when it does get degraded, but we've now lost about 80% of our earthworms, so we can't replenish the degraded soil either. Then we look at what's happening in the oceans. I already talked about what's happening in terms of climate, in terms of heat, but also we've got to look at overfishing. About 1/3 of the fisheries are now overfished across the oceans of the world, and that's going to cause dramatic shifts in ecological structures with concerning implications for humans who depend on the ocean. And in fact, we're losing our wildlife so fast that experts now say that we're entering the 6th mass extinction. Extinctions have happened in the past, a long time ago, but this time it's our fault. And that's because of how fast, not just how many creatures we're losing, but how fast we're losing them. We're now losing creatures up to 1,000 times the background rate, so 1,000 times faster than we should be losing species in terms of natural species loss. Nature is declining at rates unprecedented in human history, and it's going to have grave impacts on people around the world. So there are many different environmental bodies, scientific bodies, who have told us that we're eroding the very foundations of our economies, livelihoods, food security, health and quality of life, that we're causing the fabric of life to unravel. These are very solid, standardized scientific bodies that are issuing these reports, well-respected, high reputable sources. So this brings me to the sort of penultimate section, what is going to happen next? So the thing is, nobody really knows is the bottom line, but we do know an awful lot. So first of all, we know that at our current rates of greenhouse gas emissions, we're supposed to be reducing greenhouse gas emissions, right? Everybody knows we're supposed to be getting down to net zero by 2050. We are not. They are still rising. And at the moment, we're heading for not just a 1 degree rise, which is where we are now, but for a 1.5 degree rise since the Industrial Revolution by 2030. Remember, this is a time where we're supposed to be decreasing our greenhouse gas levels and therefore decreasing or at least stabilizing our global temperatures. So we're heading for 1.5 degrees heating by 2030, and we're heading for 2 degrees, which was the limit according to the Paris Agreement that they said this is dangerous, we mustn't go above it. We're already heading there by around 2050. And unless we take radical action now, it's not locked in, there is still time, but that is where we're currently heading, even with the policies that are in place right now. You can see that on this graph, that even with the policies that we have in place, we're heading by the end of the century to around average of around 3 degrees heating. Now that is staggering. Even with the pledges and targets that the governments have promised, we're still close on 3 degrees. And look at the error of the margin. So we could actually be heading up to 4 degrees. This is just showing that the 3 degrees, heading to 3 degrees by the end of the century. The pink bands are the emission pathways that we're currently on, as opposed to the blue bands, which really would bring us down to not get to 3 degrees by the end of the century. Now, remember, this was just 1 degree. Far right of this diagram, that was a 1 degree rise. Imagine that diagram with another 1 and another 1 by the end of the century. I mean, look at the comparison to how it's the stable climate that we've lived in over the last 2,000 years, hundreds of thousands of years. So what are we going to expect in the coming decades? I'd like to play you this short 2-minute video just to give you a sense of, according to the World Economic Forum, that have gathered some very good sources, the sorts of things that we could expect over the coming decades, unless we take radical action now. So just to add a few more things to that horrifying description, just a couple of more headline facts. Hundreds of millions of people by 2050 at the rate we're going will be exposed to extreme heat waves. 1 in 5 major cities heated to the point that unlike any currently existing city. 410 million people in urban areas regularly exposed to severe drought. These are all verified sources, and all of the sources that I've talked about are in the Emergency on Planet Earth document that Emily talked about at the start. 3.6 billion people today lack sufficient water. That will soar to 5 billion by 2050. Melting glaciers threaten to put 1.9 billion people at risk of serious water shortages. Food scarcity, Global agricultural yields predicted to be depressed by up to a third. 500 million small farms will be very affected. 5 billion people, that's half the global population, likely to face shortages of food and clean water, 1 in every 2 people. Rising seas could displace more than 300 million people from coastal cities, from their homes, which would be below high water level at least once a year. And mass migration, famine, and all of these things, everything we've talked about so far, it's likely, well, it's not possible, it's not certain, it's not impossible that that could really disrupt the very fabric of our society, taking us towards civil unrest, possibly war, and raising the terrifying possibility of societal collapse. By 2070, 3.5 billion people living in unlivably hot places. Plus, when we've got, I'm not even going to go into this because it's a whole other topic, but then we've got the possibility of tipping points being reached at any point sooner than that, and sending us into even higher temperatures than are already predicted. So that's how tipping points come into this. If we reach 4 degrees, which at the moment is possible by the end of the century, there's a sense of panic in scientists in terms of what that might look like. And I'm going to come on to solutions in just a moment, so if anyone's getting too activated by this. So it's difficult to see how a 4-degree world could accommodate 8 billion people, or even half of that. And we're heading for 11 billion. We would be heading for 11 billion by the end of the century. And there's no certainty that we can adapt to it. It just must not be allowed to occur. Earth would become an uninhabitable hell. So we do need to do something about this. We risk damages on a larger scale than the 2 world wars, hundreds of millions of people, billions having to move. So this is an emergency. I'm not going to read out all of these because if you want to look at these slides, they'll be on this recording forever. But these are just to show you that a variety of different people, scientists, doctors, UN Secretary General, economists, IPCC head, chief rights chiefs, Governor of the Bank of England, military advisors, Archbishop of Canterbury, they are all united in saying this is an emergency. So there is an opportunity to stop this, but we do have to act radically, and we do have to act now. If we want a 50-50 chance, just a 1 in 2 chance of staying below 1.5 degrees heating, which is the internationally agreed that we really ought to try and stay below 1.5 degrees heating if we possibly can, and we absolutely must stay below 2, we would need to see drastic emission cuts right now. And remember, it's not happening, they're rising. We'd need to get to net zero by 2050, and then even then we would then have to remove lots of carbon dioxide from the atmosphere, and we don't even know if that's possible. At the moment it looks like so-called negative emissions technologies to capture this carbon and suck it in from the atmosphere are just not going to cut it. They're not going to be efficient enough or good enough or stable enough to be able to do that. So even our 2050 target only gives us a 50-50 chance of staying below 1.5 degrees, and it depends on these carbon capture, which just isn't something we should be depending on. Even that would require radical transformation of our energy, industry, transport, building, agriculture, forestry, land use. If we want to have a 2/3 chance of staying below 1.5 degrees heating, which is obviously far better, far more preferable, then we need to be cutting our emission rates very, very fast. And remember, we're not cutting them. They are still going up. They've still been going up since the first warnings of climate change. Over the last 40 years, at least, they've been going up since warnings have been made by climate scientists, since the Paris Agreement, which said they need to start going down in order to stay below 2.2 degrees. They're still going up. And the good news, though, is that we do know how to deal with this. We just don't have the political or economic will to do it. And as the scientist Sherwood Rowland said, F. Sherwood Rowland, what's the use of having developed a science well enough to make predictions if in the end all we're willing to do is stand around and wait for them to come true?